In today's video, we are going to explore the fascinating world of ultrasound and understand exactly how it works and how this powerful technology is used in various important areas such as prenatal scanning, industrial imaging, and sonar systems. To begin with, what we mean by ultrasound is simply sound that vibrates at frequencies higher than 20,000 Hz, which is above the upper limit of human hearing. While some animals like bats naturally produce these ultrasonic waves for activities such as communication and echolocation, humans are not capable of generating ultrasound naturally and must rely on specially designed electrical devices. These devices create ultrasound in a manner quite similar to how a standard speaker works by generating electrical oscillations that are then transformed into sound waves. However, in the case of ultrasound devices, those electrical oscillations are specifically converted into ultrasonic waves. Now, when ultrasound waves encounter a boundary between two different mediums such as air and water, a portion of the waves are reflected back while the rest are transmitted through and refracted. This process is known as partial reflection because only some of the ultrasound waves bounce back while others continue on through the new material. Because of this, if we send out ultrasound waves toward an object, the waves that pass through will reflect back at every boundary they encounter. By knowing the speed at which the sound waves travel and measuring the time it takes for the reflections to return, we can accurately calculate the distance to each boundary. Repeating this process for multiple reflections allows us to build a picture of the object's internal structure. Fortunately, ultrasound is a completely safe technology with no harmful radiation, making it ideal for use in a range of fields. One of the most well-known and widespread applications of ultrasound is in prenatal scanning, where doctors use it to safely observe fetuses during pregnancy. This is done by placing an ultrasound probe that can both emit and receive ultrasound waves onto the pregnant woman's abdomen. The device sends out ultrasound pulses which travel through the body, and every time they pass from one material to another, such as from muscle tissue to the fluid surrounding the fetus, or from that fluid to the fetus itself, a portion of the waves are reflected back. The ultrasound machine records the timing and intensity of these echoes and processes them using a computer to create a real-time image of the developing fetus, which can help medical professionals assess the baby's health and development. Another vital use of ultrasound is in industrial settings where it is employed to inspect the integrity of manufactured products. For instance, if we send ultrasound waves through a solid metal component, the waves should travel through the object and only reflect at the beginning and end where there is a change in material. However, if there is an internal fault such as a crack, some of the ultrasound waves will bounce back at the location of the crack, and by analyzing these unexpected reflections, companies can detect and diagnose defects within the material that are not visible from the outside. The final major use of ultrasound that we will examine today is in sonar and echo sounding, which are methods used by boats and submarines to determine the distance to the seafloor or to detect underwater objects. In this method, a submarine, for example, sends out a pulse of ultrasound which travels through the water at a speed of approximately 1,400 meters per second. If that pulse reflects off the seafloor and is detected back at the submarine 6 seconds later, we can use the formula distance equals speed multiplied by time to calculate the total distance traveled by the sound wave. In this case, we multiply 1,400 meters per second by 6 seconds, which gives us a total of 8,400 meters. However, since the sound wave traveled to the seafloor and then back again, we must divide this distance by 2, meaning the actual distance from the submarine to the seafloor is 4,200 meters. This method allows for accurate depth measurements and is widely used in navigation, fishing, and underwater exploration. That concludes everything for today's video, and we hope that the explanation made the topic of ultrasound much clearer. If you enjoyed the content and found it informative, please consider liking the video and subscribing for more science topics in the future.